All right, let me go over this is chapter 4 review, morning review session. This is the calculator portion. So first, you want to make sure that you are in Radian mode. You should always be in Radian mode whenever you're using your calculator. So we have our velocity function given by t cosine of pi times t over 6. And first thing is to create a sine line for velocity and acceleration. So we can simply plug in the calculator here as x cosine of pi x over 6. And in my graph, I adjusted my window to go from -1 to +12, just so I can have some range in the window outside of what's given from 0 to 11. And you can see that we have 3 x-intercepts here, and they're all going to land nicely on whole numbers, so 0, 3, and 9. And also endpoint is at 0 and 11. So from 0 to 3, we see that the graph is above the x-axis. From 3 to 9, below the x-axis, so negative velocity. And between 9 and 11, above the x-axis, so therefore positive velocity. For acceleration, the critical points will be the max and min. So we're going to be just trying to find these max and mins. And we can simply use the max and min feature under second trace, which is calc. So for instance, if I want to find the maximum for this region here, I can go enter in a left bound of 0, then enter in a right bound of 3, and that will get me the maximum value will occur at the x value of 1.643. And we do the same thing for the minimum feature for this point here, and this will give us 6.542. Positive slope means increasing positive acceleration. Negative slope means negative acceleration, and then positive slope here represents concave up or positive acceleration. Okay, so we have this information which we're going to be able to use in the following sections. So part B, find the times when the object is motionless. So we found from the graph that the intercepts are at 0, 3, and 9. For part C, find the velocity of the object at t is equal to 4 seconds. And y sub 1 is holding the velocity function. So if we simply use the calculator and call y sub 1, go to the home screen, call y sub 1 parentheses 4, this will plug 4 into the velocity function and evaluate this for us. And we're going to get -2 inches per second. And then t, we also want to indicate that this is seconds as well. And to get to this, you're going to simply go to vars, y vars, function, and then y sub 1 from your home screen. For part D, find the acceleration of the object at t equals 4 seconds. Acceleration is simply the derivative of velocity. So I can use the n-deriv feature in the calculator to help us evaluate the derivative of this velocity function at 4. So n-deriv y sub 1, which holds the velocity function, comma x, that's the variable, and 4 is the value we want to plug in. So we're going to get -2.314, and unit of measurement is inches per second squared. Part E is the object's speed increasing or decreasing. So to determine this, we simply compare the signs between velocity and acceleration. Velocity is a negative value. Acceleration is also a negative value. So therefore, speed is increasing because we have same signs between velocity and acceleration. They are both negative. Okay, part F, find the total displacement of the object from 0 to 11 seconds. And total displacement is simply going to be the definite integral of v of t from 0 to 11. And we can plug in our calculator using FN integral feature. So this is under math 9. Y sub 1, this holds the velocity function. X is the variable. 0 is the lower bound, and 11 is the upper bound. So we're going to get negative 10.993 inches. For part G, find the total distance of the object from 0 to 11 seconds. Again, we want to show integral notation. So the definite integral of the absolute value of v of t from 0 to 11. So the only adjustment we have to make is we have to call the absolute value of y sub 1. So f in integral, absolute value. So to get to absolute value, you're going to go to math, number, and the first option there is ABS. Okay, y sub 1, x, 0 is the lower bound, 11 is the upper bound. We're going to get 34.844 inches. So this is taking all the regions above and below the x-axis, making them all positive and adding them together. Part H, find the time when the object reaches a minimum velocity. So if we look at our graph, we can tell that the minimum velocity will occur at this point here, right? And simply at this point, we found from part A to be 6.542. And if we go through the minimum feature to identify the y value, we're going to see that the velocity at the 6.542 is going to be negative 6.28 inches per second. Okay, so simply we're just trying to find the ordered pair at this point. Okay, part J. Given x sub 0 equals 3, find x sub 11. So we want to find the position at time is equal to 11. To do that, we first need to identify our starting location, which is x sub 0, plus the definite integral from 0 to 11. So the displacement from our starting point will give us our end position at 11, at 11 seconds. So we know this information from part F, which is simply going to be equal to negative 10.993 inches. So we replace the definite integral with the given value, plus 3 will give us negative 7.993. So we have our position. X sub 11 is equal to negative 7.993. Okay, part K. Find the average velocity. So we're simply going to be using the average value theorem, 1 over b minus a, definite integral from a to b of v of t dt. So from 0 to 11, v of t dt, we found this from part F, and we used it in this last section as well for part J. Simply going to be negative 10.993, which is to make sure we divide by 11 to identify our average velocity, which in this case is negative 0.999 inches per second. Last part here, find the times when the object reaches average velocity. So to find this, we're going to set our initial velocity function equal to negative 0.999, which is our average velocity. We want to find out when is the velocity graph going to cross this, or when is this velocity graph going to hit this average velocity of negative 0.999. So we can use our calculator to help us with this. Take our initial velocity function, set it equal to negative 0.999. We're going to bring this over to one side, and all this plug into the equation, into y sub 2. I'm going to plug it into calculator as y sub 2. Graph it, and simply look for the x-intercepts. So in our calculator, okay, I have it entered in as x cosine of pi x over 6 plus 0.999. And when I hit graph, I'm going to see 2 points, 2 intercepts, and they're going to be at 3.546 seconds and at 8.782 seconds. So to find these points, we can simply use the 0 feature under calc So go to second trace. Okay, go to second trace. Just click on hit 0. And left bound is 0. Right bound being 4. And we can identify our first x value being 3.546. And we're going to repeat that to find, we can choose values between 7 and 9, and they will locate the other x-intercept, which is at 8.782 seconds.